Hello everyone and welcome to the channel. Now this is going to be the most requested question of this session on the channel, right? So all of you were requesting me to make this particular video for the solution of physical chemistry, basically physical chemistry questions of the CSIR December 2019 exam. So I have tried to bring up all the questions which were asked from physical chemistry in the section B. Okay, in the section B, that means all the 2 marker questions which was asked from in the CSIR December 2019 exam. And remember, these solutions are for the exam which held on 15th of December. Okay, that was the exam which held in all India except in the Assam and Meghalaya region, right? So for the Assam and Meghalaya region, I'll be posting the video like soon. And I request you, if anybody of you has if anybody of you have that question paper of Assam or Meghalaya region, then do send it to me, because I have, but it's not complete. I have some missing questions in that. If you have complete question paper of that particular region, you can you can send it to me. It will be of a great help. All right. So now we'll take this all the solutions. Now, first of all, before going into that, let me just tell you that what is going to be exciting of this video. First thing is that I'll be going in detail. Okay, the solution will be in detailed solution. Okay, so solutions will be in detail, and also I'm going to discuss many shortcut tricks. Okay, so shortcut tricks you are going to get in this particular video of many questions. So stay tuned and watch this video completely and very carefully. All right, so let's start with the first one, and the first one is the most amazing question, which I can say, like, it's not that difficult. It was easier one, and I have already posted videos on this kind of questions based upon the hydrogen atom problem, and where the atomic orbital or the wave function is given, and you have to tell that which orbital it belongs to, right? Now this is a wave function, right? So I can represent it as psi is equals to nr square e to the power minus r by 3 a naught, and it's like 3 cos square theta minus 1. Now it has two parts, right? This particular part is called as the radial part, okay, radial part, and this particular part is called as the angular part. Now there are two things, okay. You can easily find out the value of L. Okay, you need to find out basically the value of n, that is principal quantum number, and the value of L, that is azimuthal quantum number. So once you got these two, you can tell that which orbital and which orbit it is actually going to belong. So the value of L is actually equal to the maximum power, okay, max order or power of the angular part, okay, of cos theta. So whatever is the maximum power of the cos theta, that's going to be the value of L. That's how we decide it. So for this particular question, you can say that L actually is equal to 2. Okay, so L will be equal to 2. Now how to do the radial part? Now I'm going to explain you two ways. Okay, just like you did, just like you found the value of L, in the same way you can find out the value of N as well. The shortcut way is that in the radial part, your e to the power minus r by n a naught. Okay, so it's written in this particular form. So it's like minus z r basically. So minus z r by n a naught, where n will be your principal quantum number. So from there you can say that n is equal to 3. So it's quite simple, right? It's the simplest way or the shortcut trick how to approach this. But if you want to if you want to recheck this, or if you want to do with a normal method, the usual method, then I will explain you, and this is going to be helpful, or this is going to be exciting for those who love physical chemistry, those who like questions from quantum mechanics, right? So for them, I'm just going to give you a different approach. So what you can do is you just have to see that how many nodes you have, okay, just total number of nodes. So for total number of nodes, you have to take the radial part is equals to 0, right? So that means what you have to do, that n r square e to the power minus r by 3 a naught, you have to take it equal to 0. Now this the left hand side of the equation can be equal to 0 in two cases. If the value of r is either 0, then this particular will become 0 and everything will become 0, right? And if it is 0, then e to the power minus 0 will be 0, and this part will become 1. So that means overall this particular part will become 0 if r is equals to 0, and if r is equals to infinite. If I put r is equals to infinite, e to the power in minus infinite will be 0. Okay, so when this particular part becomes 0, everything from the left hand side becomes 0. Okay, remember this thing, that e to the power minus infinite is equals to 0, and e to the power infinite is equals to infinite. So this thing you should know. Yeah, so these two, both of them are actually your boundary condition. Okay, both of them are boundary conditions. Now if both of them are boundary conditions, so that means what? There is no node present in that. So total number of nodes will be become equal to 0 actually, because there is no node. There is either 0, which is at the origin of the wave function, like if it is like something like this. Okay, so it goes like this. So it's not becoming 0. You are not getting any node of this. So this is how you can make this wave function in the form of. So yeah, now total number of nodes is equal to 0. Now you know the formula of total number of nodes, right? It's n minus L minus 1, and that is going to be equal to 0. You already have the value of L, you can put it over here. So n, let's say I want to calculate, L is 2 minus 1 is equal to 0. So from here also you got n is equal to 3. So this is the usual way of solving and finding out the n, and this is the most appropriate way. Okay, although you can get in the simpler way, in the if you don't have much time, you can go for the simplest way and you can get it. But believe me, this by doing these kind of methods, you will understand more of mathematics, you'll understand more of wave function, you'll understand more of quantum mechanics. So yeah, n is equals to 3, L is equals to 2. Now you know that L is equals to 0, 1, 2, 3. So it is given by S, P, D, F, right? So for 2, L is equals to 2, you have D, right? So the answer should be 3D. So the answer will be 3D orbital. So that's how your answer is option number 3. So that's how this has to be done. Let's go to the next question then. Okay, the next one is from your molecular spectroscopy, and it says that the frequency of OH stretching occurs. Yeah, so the frequency of OH stretching occurs, and what they are asking is like this is given that 3600 centimeter inverse is where the stretching occurs. They're asking about the OD stretching frequency. So this can be done like you know this formula, right? Mu is equals to 1 upon 2 pi under root k by mu. That's the formula where mu is your reduced mass. So what you can say that if you are talking about nu OH divided by nu OD, so that will be actually equal to under root. Okay, you can just take the values and rest of the things will be cancelled out, and you will have under root of mu OD by mu OH. Okay, that's how you can put, and that's how you can solve. Now you just have to calculate this mu OH and OD separately using this formula, that is mu is equals to m1 m2 divided by m1 plus m2, where m1 and m2 are the masses. For OH you have to take mass of one of the mass will be 1 and oxygen will be 16. For OD 16 and plus 2. Okay, so that's how you have to put, and you have to calculate both the masses. You have to put it over here and then solve. So this is the usual way. Okay, the shortcut method or the thing which you can remember is this, that whenever it is asked, okay, whenever it is given that you have frequency of OH and OD, then remember this thing, that frequency of OD divided by frequency of OH is actually like it's approximately, okay, it's approximately equal to 1 by 2 or 1 by under root 2. Okay, or what you can say, that frequency of OD is going to be 1 upon under root 2 times of your frequency of OH. Now that is how your answer is going to come. So if you put it over here, it's 1.414, and into the value of this that was given 3600. Now when you solve this all, you will get something around 2545 something like that, and point something. So yeah, it's quite near to this value, that is 2600. So that is going to be your correct answer for this particular question. I hope you guys understood, right? So this is the shortcut trick which you can memorize, which you can just note it down somewhere. This is going to help you a lot anywhere if it is asked between the frequency of OD and OH. Okay, let's go to the next question from the solid state chemistry. It says that the Miller indices of the plane as shown in the figure and parallel to the c-axis are. Now what it is given, that the plane over here which is drawn is actually along the two axes, axis A and axis B, and it's along like perpendicular to the yeah, it's parallel to the c-axis. Now remember, first of all you have to do like you have to find out Miller indices. The way how we find out Miller indices is, first we calculate the V's indices or we calculate the intercept. Okay, so first thing is that I am going to calculate the V's indices or intercept. So if a particular plane, okay, I'll write down A, B and C, all the three intercepts. Okay, so I'll write down the intercepts over here. So yeah, since the plane is parallel to any axis, if something is parallel, if any plane is parallel to any axis, this is very much clear that that particular plane is going to strike, or it's going to make an intercept at infinite. Okay, so a plane parallel to any axis is going to make the intercept at infinity. So the V's indices, or the intercept of the C for the C axis, is going to be infinite. That's what you can write down, because it is given that it is parallel to the C axis. Okay, so that's how you can say. Second thing which you need to know is that like, just from the diagram you can see now you have B axis over here, okay, and you have A axis along this direction. So you have to just take this one length as one unit. Okay, so it's 1, 2, 3 and 4. So on the A axis the intercept is coming out to be 4, because I'm just writing the intercept. And on the B axis it's 1 and 2. So on the B axis the intercept is 2. Okay, so these are the B indices of the intercept. Now the method to find out Miller indices is that, first of all, you have to take reciprocal of it. So when I take reciprocal, it will become 1 by 4, 1 by 2, and it will become 0. Okay, because reciprocal of infinite will be 0. Now the next thing is that what you have to do, you have to make it a integer of it. We have to multiply with the biggest number here. So I am going to multiply this whole with 4. Okay, so I'm going to multiply all of them with 4. So it is going to become 1, and it is going to become 2, and it is going to become 0. So the Miller indices for this particular plane is going to be 1, 2 and 0. So it was very, very simple question. Okay, if you have done questions based upon Miller indices, and if you know, if you understand that what parallel to a particular axis means, you could have done this question very easily. So that's how this has to be. Alright, let's go to the next question then.
Alright, let's talk about this particular question. Now, it was asked from your electrochemistry part, and it says that the cell potential in volt of silver electrode is given. Ag is getting converted into AgCl electrode connected to standard hydrogen electrode. Okay, at 298 Kelvin is closest to. Okay, standard electrode potential is given to you, that is 0.222 volt, and assume that the activity of KCl is given, and that is 0.01. That's the activity given to you. Okay, now fine, how to solve this particular question? See, it's going to be like, to solve this particular question you need to know some things, right? Some basic things you should know the idea about that. First of all, how to find out that what is going to be on anode and what is going to be on cathode, that is going to be the first thing which you have to decide. Now for that you should understand about simple hydrogen electrode. Now simple hydrogen electrode is always connected, like, it is, you know, that it is used, okay, it is used to measure reduction potentials, right? It is used to measure reduction potential. And if it is used to measure reduction potential, so where it will be always connected to, so it will be connected to anode. Okay, so it will be always connected to anode. Now where does this particular electrode goes to? So this particular electrode will go to cathode. Okay, and there will be reduction happening in this particular reaction. All right, so yeah, so this particular like, what is going to happen at cathode? So at cathode, your reaction of your Ag getting converted into AgCl and KCl is going to happen. Okay, that's what you are going to get over here. Now you know the Nernst equation, right? Now E of the cell is equals to E naught minus 2.303 RT upon NF, and you have log concentration of product divided by concentration of reactant. Now that is one of the formula which you can put over here, or log reduction upon log like reduced species upon the oxidized species, right? So that's how you can put it, and you can solve it. Now one thing which is going to be possible over here is that at 298 Kelvin, this particular value, that is 2.303 RT upon F, it's going to get converted into 0.059, right? So that is one thing which can happen. Now you have to understand the reaction which is happening at the cathode. So let me just write down that. So at cathode, basically what is going to happen, that since the reduction you are looking onto reduction, so this AgCl is going to take one electron and it is going to get converted into AgCl minus. There are many ways in which you can write down. Either you can write down in this way as well, that this is going to get converted into Ag as a solid, or as a neutral species, and chlorine ions. So yeah, this is how the reaction is actually happening at the cathode, right? So based upon all these things, what you can see is that in the solution, in the whole complete solution, so yeah, you have to find out the overall cell potential. Yeah, that's what you have to calculate. And in this particular reaction, there are two things which you don't know. Now E naught you already know. Okay, you don't know, that is n, the value of n, and the value of what you are going to put over here, the concentration of product and reactant. Now for that, you should be aware about this thing, that in this reaction, in the cathode reaction, whatever you are getting is only chlorine ions as the ionic part. Apart from that, all the other things are actually in the solid form, all the other things are in the salt form. Okay, so they are all, or the in the reactant part, if you see, you have AgCl, which is salt, so the concentration of reactant is going to be 1, whereas as the concentration of product side, you are going to write down the concentration of chloride ions. Okay, so that's what you are going to write down. So that means we got to know one thing, that this particular equation can be actually written as E is equals to E naught minus 0.059 upon n, and it is going to be log and chlorine ion concentration. Okay, so this is one thing which you can do. Now in the place of n, you have to write down the number of electrons which are given or taken in the reaction step. So here you can see that there is just one electron which has been taken, so the value of n I got as 1. Concentration of chlorine, from where I am going to get the concentration of chlorine? Now you can see that the only thing that can be completely dissociated to form chlorine ion in the solution is your KCl. Okay, because this AgCl is a insoluble species, and it is not going to dissociate completely. Okay, so that means the only thing which is going to dissociate and it is going to give you chlorine ions or chloride ions is your KCl in the reaction. So that is why the activity of KCl is going to be used over here. Okay, so that's where you will take that thing. So the concentration of chlorine will be equal to the activity of your KCl, right? The concentration of chlorine will be actually equal to activity of your KCl. Okay, because you know that, right? Because you just have one charge on it. So like chlorine ion just have one charge, so you can directly get it to this. Now you just have to put the values, and that's how you will get the answer. So E is equals to E naught minus 0.059 upon n will be 1, and it will be log, and this is going to be 0.01, right? Now you just have to solve this, and I'm going to put all the values. So it will be 0.222 minus 0.059 into log 0.01 is going to be minus 2, right? So that's what we will get. This minus and this minus will become plus. It will be 0.222, and plus it will be the twice of this 0.059 is going to be 0.118. If you add all of them, you are going to get 0.340 volts. So that is going to be the answer. Option number 3 is going to be the correct answer for this particular question. That's how this has to be solved. I hope this is quite clear to you. In this particular question, there were two concepts which were used. First thing is that you should know about standard hydrogen electrode, and the first thing is to decide that where your cathode will be and what your anode will be. Second thing, the reaction of your silver electrode. That's what you need to know. And third thing is that how you can relate activity with the concentration, and how you can put that value over here. So that's how your option number 3 is going to be the correct option for this question. Now let's go to the next question now. Okay, so the next question is again a very simple question from your thermodynamics. Basically, it says consider the entropy changes in the system undergoing transformation as depicted in the diagram below. The diagram is given to you, and it's given that the correct statement among the following is. Now try to understand this diagram. What you are doing is actually you have something at 25 degrees Celsius. You are trying to convert that the conversion you are making up to 50 degrees Celsius, and the change in entropy over here is happening is called as delta S1. Then again you are doing some changes at 75 degrees Celsius, and the change in entropy is delta S2, and delta S is the direct change in entropy from 25 to 75. Now that means what? Actually what you are doing is you are starting from 25 degrees Celsius and you are going till 75 degrees Celsius, and you are going through two paths. This is path number 1, P1 path, and this is the path number 2, that is P2 path. So two different paths have been followed for this. Now, to understand this or to answer this, the basic funda of your of your thermodynamics you have to apply over here is that your entropy, okay, entropy is a state function. Okay, so entropy is a state function. That means what? It is not going to depend upon the path which is being followed. So whatever path you are following, your overall entropy is going to be same. So that suggests that delta S has to be equal to delta S1 plus delta S2. Okay, so overall, whatever, if you do it through this path also or through this path, the overall entropy is going to be same. So that means what? You can easily cancel out option number 1 and option number 2, which says that it's unequal. Okay, so you can just cancel out the first and second option. Now you also have to relate between delta S1 and delta S2. You have to relate these two as well for the first part of it. So now let's try to understand that. So from the second law of thermodynamics, we know that the change in entropy is actually equal to Q upon T, or you can say Q of the reversible process by T. So that means what? I can say that the change in entropy or delta S is actually inversely proportional to temperature. Remember what I'm saying? I'm not saying entropy is inversely proportional to temperature. I'm saying change in entropy is inversely proportional to temperature. Okay, so that means if temperature increases, my change in entropy will decrease. That's what it is. So that means what? When the delta S1, that's what we are doing at 25 degrees Celsius, you are doing it at lower temperature. Okay, so the entropy of that is going to be more. Okay, whereas delta S2, which you are doing at 50 degrees Celsius, so the temperature is higher, so the entropy will be less over here. Okay, so lower the temperature, higher the entropy. So that means what? That means delta S1 is going to be greater than delta S2. So by that I can say that my option number 4 is going to be the correct option for this particular question. Alright, so I hope this you guys understood that how we have solved this one. Now let's go to the next question then. Alright, so this one is again from capillary action basically, and the question over here, it says that a liquid of density 1.1 gram per centimeter cube and climbs to height of 5.0 centimeter when a capillary with internal radius of 0.2 millimeter is dipped into it. The surface tension, okay, the surface tension they are asking. So you have to answer surface tension. But yeah, one thing which being a physical chemistry student you should know is that the units you have to focus more on. So the unit you can see over here, the unit of density is grams per centimeter cube, which is a CGS unit. Uh, Height is also given in centimeters, so again it's a CGS unit. Radii is even smaller unit, that is millimeters, but the surface tension is asked in newtons per meter. That means in the SI unit or in the MKS unit. So the first thing is that you have to convert everything into the MKS unit and then you have to answer it. So to answer this particular question, there is a direct formula. Okay, if you know that formula, you can do this question. Otherwise, it is difficult to do. Okay, so you know the surface tension. What is surface tension, right? So surface tension is the force which is applied on the surface of the or the on the surface molecule of the fluid, which tries to make the shape of the fluid minimum, right? So yeah, surface tension is given by this formula. It's denoted by actually gamma, and your gamma is equals to, gamma means your surface tension over here, and it's equals to h r rho g divided by 2, where what are these things? H is the height, r is the radii, rho is the density, and g is your acceleration due to gravity. Now the value of g, you know that it's 9.8 meter per second square. So that's the unit of your g. You just have to put all these values over here and you will get the answer. But remember what I told you, that the value should be in the MKS unit. So the height is given 5 centimeters. So let me write down in meters. So it's 5 into 10 to the power minus 2. Okay, that will get converted into meters. Radii is in millimeters, so that's 0.2 into 10 to the power minus 3. Again, it will get converted into meter. I'll just write down here the units as well. Okay, and then the density is in 1.1 grams per centimeter cube. If you have to convert grams per centimeter cube into kilograms per meter cube, so for that, remember this thing, that 1 grams um, 1 grams per centimeter cube. If you have to convert this into kg per meter cube, okay, you have to convert in this way, in that particular form. You have to multiply with 10 to the power 3, okay. So yeah, you have to multiply this particular part into 10 to the power 3, which should be equal to 10 to the power minus 3, yeah. So yeah, so that means what, 1 grams, uh, yeah, so that's how it will get converted into kg per meter cube, okay. So we have just converted the units over here and divided by 2. All right, and yeah, g is also there, so let me just put that. So 9.8, it's already in meter per second square, so we don't have to do anything with that, it's already in mks unit. All right, now you have to solve this, that's it you have to do. So either you can go in a robust form and you can just keep on solving it, or you can just apply some approximation to solve it. You can see over here that it's 9.8 and it's 1.1. If you just multiply these two terms, you will get something around 10, right? Because 9, if you multiply with 1, you will obviously get 9, okay. And it's 9.8, which is quite near to 10, and 1.1, which is quite near to 1. So 9.8 you can say approximately equal to 10, and 1.1 approximately equal to 1. So 10 into 1 will become 1, okay. So this whole multiplication of these two, I can say it's approximately equal to 10. Now the things will become quite simple for me. So 5 into 10 to the power minus 2 is already here. Then I have 0.2 into 10 to the power minus 3 here. Then I have 10 into 10 to the power 3, okay, this 10 to the power 3 was there, and divided by 2. So now I can say that my 10 to the power minus 3 and 10 to the power 3 will get cancelled up. 0.2 and 10 will get multiplied and they will become 2, and they will cancel out this 2. So my answer is going to be 5 into 10 to the power minus 2, or it is going to be 0.05, and this is going to be the correct answer, option 1, okay. So option 1 is going to be the correct answer for this particular question. You don't have to do full calculation. If you will do full calculation also, you have to round off, and then again you will get option number 1, okay. So that's how you will do this particular question. So it's just based upon this direct formula and the unit conversion, that's it, okay. So that is how this has to be done. All right, so the next question is from your chemical kinetics. It says that the rate constant for the base catalyzed ester hydrolysis reaction is 0.2 liters per mole per second. Half life in seconds for the ester, and it's given that the initial concentration of ester or initial concentration of base is actually 0.05 moles per liter, would be closest to. So you have to tell the half life time. Now, if you look upon the question again, you will see that there is nothing given about the order of the reaction. Order of the reaction is not given, but that you can easily find out through the unit of your rate constant, right? So, the general unit of the rate constant for the nth order reaction, your Kn is actually having this unit. It has moles to the power 1 minus n, liters to the power n minus 1, and second inverse, okay. So that is the unit of your Kn. Now if you try to look upon it, this particular value is actually for your second order reaction. So liters per mole, sorry, liters per mole, and second inverse is actually for your second order reaction, okay. It's for second order reaction. So that means what, this reaction is a second order reaction, and your K2 value is given, that is 0.2 liters per mole second inverse. Okay, you have to find out the T half. So T half is given by this formula for the second order reaction. You know the formula, right? It's 1 upon A naught and K2. That is the formula to calculate T half. You just have to put the values, and that's how you are going to get the answer. A naught is the initial concentration of ester, so that is 0.05, so it will be 1 upon 0.05, and since the unit is already in moles per liter, it will get multiplied with by moles per liter per moles, so that will cancel out each other. So 0.2, so the units will get cancelled out, only you will get 1 upon second, or you will get answer in the seconds. So the answer, I'll just try to convert this. So if I remove this, I will get 100 upon 5, and it will be 10 upon 2. So 5 into 2 is 10, so it will cancel out this 10, and you will get 100 as the answer. So the correct answer is going to be option number 2, and that is 100. All right. Okay, so let's go to the next question then. Okay, so the next question is from your um, yeah, so this particular question is based upon the chemical potential, okay, and it's from your thermodynamics part. It's given that the molar composition of a mixture of P and Q at equilibrium is 3:1. A small disturbance in the composition results in change of the chemical potential of P by 10 joules per mole. The chemical potential of Q will change in joules per mole is, okay. So you have to tell how much it is going to change. Now this is being asked from a very famous equation of your thermodynamics called as your Gibbs-Duhem equation. Okay, so Gibbs-Duhem equation. How to use this? Let me just tell you that. So in the Gibbs-Duhem equation, we have our delta G, and it is actually equal to the summation, the sum over of D of Ni mu I, right? Where Ni is the number of the ith part or ith uh, component, and mu I is the chemical potential of that. Okay, so you know one thing that what will be the, like, yeah, here you need to know two things. Rest of the things are given to you, the ratio and the other things and the chemical potential as well. The only thing which is not given is your Gibbs free energy, right? So that you have to use through the text itself. You have to just understand from the question itself. It is given that the condition is equilibrium. Okay, so at equilibrium we know that dg is actually equal to 0, right? The Gibbs free energy at equilibrium is equal to 0. Okay, so at equilibrium, your dg will be equal to 0. So that means what? It means, if you just write it down, so at the place of dg I'm just going to write down 0, and this, if you open up, so there is no change happening in the number of components, right? So you don't have to differentiate that. It will become like this. So n, I'm just writing it like this: np and d mu p. That means what? Np is the number of composition or the p component, and d mu p is the change in chemical potential of for the p component, okay. And plus it will be nq and d mu q. That means number of q component into change in the chemical potential of the q component, all right, and overall it will be equal to 0. So let us put the values. So you know that it is in ratio 3:1. So we can say that np is actually equal to 3. Let's take it as 3, and nq, let's take it as 1, and d, chemical potential, change in chemical potential of p is given. So d mu p is actually given to us 10 joules per mole. So let's put the values over here, and we have to calculate this particular part. So np is going to be 3 into 10, and plus it will be 1 into d mu q, and that is going to be equal to 0, or you can say that d mu q is equals to minus 30. So that is going to be your answer, minus 30 joules per mole. So the answer is going to be your option number 3. So option 3 is going to be the correct answer. That's how you have to do, just based upon your Gibbs-Duhem equation. Alright, I hope you guys understood this question, and you liked how it is being solved. Now let's go to the next question. Alright, so this particular question says that a cube does not have the symmetry element. Which of these symmetry elements does a cube does not have? So if you have solved questions based upon symmetry and based upon group theory, you could have done this question very easily. Let me just quickly draw a cube and just show you that which axis will be there and which will not be there. Okay, so it is asked that which is not going to be there. So let me just draw the cube first. Alright, so when we talk about a cube, you can see over here, so there are there are many kind of symmetry elements which are there in the cube, and if you have studied group theory in detail, you might easily understand that how these axes will be there. So the one which you can see right now on the screen, this axis is actually a C3 axis, which passes through the body diagonal from this particular point to this particular point, okay. So if you join these two particular points, you get a body diagonal, and if you rotate the cube along this body diagonal, you have to rotate it by 120 degree to get the identical image. So yeah, you will be able to understand it more in more detail when you try to see it in 3 dimension. So there are many websites which offer you to look at a particular molecule in 3D. So I'll suggest you to go over there and watch the molecules in 3 dimension over there, right? So there is a C3 axis. Okay, so C3 axis is there. All right. Now this particular axis which is just shown is a C4 axis, because if you rotate it, it's around, like, it's from the center of the face. So 1, 2, 3, and 4, these four groups are going to interchange their positions if you rotate it by 90 degrees, right? So there is a C4 axis, so obviously that is also there. And again there is a C2 axis also, which passes through the center of this particular this side. If you just take the center of this side and you take the center of the opposite side, which is on the back side, so the axis passing through these two is actually C2 axis, because that is going to interchange this 1 2 group and this 3 4 group. So if you rotate it like this, so your 1 2 group is going to come at the place of 1, 3 is going to go at the place of 4. So C2 axis is also there. The only axis which is absent in a cube is your C6 axis. So that is going to be the element of symmetry which is not there. So option 4 is going to be the correct answer for this particular question. Alright, I hope this is much clear to you. Let's go to the next question then. Alright, let's talk about this question here. It was from your statistical thermodynamics. It says, consider a two-level system in which the excited state separated from the ground state by energy epsilon, okay, is a doubly degenerate. So the excited state is doubly degenerate and it's separated by energy epsilon. The fraction of molecules in the excited state is. So let's try to draw the system first of all. So we have something in the ground state and we have something in the excited state. The excited state thing or excited state has a degenerate energy level, and the energy difference between these two energy level is actually epsilon. So let me put the energy value of the ground state as 0 and the energy value of the excited state as epsilon. Okay, so let it be E naught is 0 and E1 is epsilon. Okay, so that's what I have given, so that the energy difference becomes epsilon. The degeneracy of this will be denoted by G1 and this is equals to 2, and the degeneracy of the ground state is 1, okay, because it's singly degenerate. So these are the informations which are given to you. You have to find out for the t is equals to infinity, like t turns to infinity. So for that you have to find out the relation, or you have to find out the fraction of molecule in the excited state. So that you can do easily from this formula, that is, let's say if you have Ni upon N upon capital N is actually equal to Gi e to the power minus Ei by kt, and divided by the sum of all, right? The sum of your Gi e to the power minus Ei by kt. You know this formula, right? Divided by the partition function basically. So if you put the values, so here your you have to find out it like this. So n1 upon n is actually equal to G1 e to the power minus E1 by kt, and divided by your G0, okay, e to the power minus E0 by kt, and plus G1 e to the power minus E1 by kt. Okay, so that is what we are given with. We just have to substitute the values to calculate the answer. Now one thing which I want to tell you over here is that if your t turns to infinite, that means what? That means 1 by t will turn to 0. Okay, 1 by t will become equal to 0, and your e to the power minus 1 by t will be actually equal to e to the power minus 0 or e to the power 0, and that is going to become 1. So whenever your t turns to 0, all these values of e to the power is going to become 0. So let me just put up the values first of all. So n1 upon n is actually going to be equal to 2 into e to the power minus epsilon by kt, and divided by 1 into e to the power 0, because E0 is 0, right? And plus 2 into e to the power minus epsilon by kt. So when the t turns to 0, so when t turns to infinite, all these terms are going to become equal to 1. So what I am going to get is n1 upon n is equals to 2 upon 1 plus 2. You will get 1 from here, right? So your answer will be 2 upon 3, and the correct option comes out to be option number 3. That is how you will get the correct answer. So that's the usual way of doing it. Let me just tell you a shortcut trick how to do this. So remember, whenever your t turns to 0, okay, if your t turns to whenever your t turns to infinite, and for anything any question related to your the probability function, the fraction of the molecule, or the population of the molecule is being asked, in that case you can use this formula, that is Ni by n that is going to be equal to gi and divided by sigma gi. That's all you have to do. Okay, so you just can use this formula to get the answer. If you just use this, you can again get 2 by 3. You don't have to solve this much of it. So remember, when the t tends to infinite, all the powers, all the e to the power terms will become equal to 1. Only left out will be only the degeneracy terms, and that's how you'll get the answers. Alright, so I hope this was much clear to you. Let's go to the next question then. Alright, so this question over here is actually from your polymer chemistry, and what they're asking is the titration of 4.4 gram of polymer having carboxylic acid end groups requires 11 ml of your 0.02 molar NaOH. So the average molar mass of the polymer is. So what they're asking is average molar mass. So let's try to understand first of all that since it is given that titration of this much gram of polymer having carboxylic acid end group. Okay. So what will be the number of your polymer molecule? So number of your polymer molecule will be actually equal to the number of carboxylic acid groups, right? Because this is going to be at the end of the group. Okay, it's given that carboxylic acid ends are given. So number of carboxylic acid group is going to give you the number of polymeric molecules. Now, in order to find out the number of carboxylic acid or the moles of carboxylic acid, you can do that because that is going to be titrated against NaOH. So you just need to find out that how many moles of NaOH is being required to titrate this COH. Okay, so let's try to find out the moles of NaOH. Okay, so the moles of NaOH will be given by this particular formula, the molarity of your solution and into the volume. Okay, so that's how you can do, but the volume should be in liters. So you know this formula, right? It is from your class 12 onwards. Like the formula is from your class 12 because the molarity is number of moles per liters. So if you multiply the molarity with the volume, you'll get number of moles, right? So that's what the idea is basically. So the number of moles, or sorry, the molarity is given, that is 0.02 molar, and the volume is given in ml. So let me just convert that into liter. So that is going to be 11 into 10 to the power minus 3 liters, and the answer which we will get will be 2.2 into 10 to the power minus 4 moles. So this much moles of NaOH we have. Now we know that NaOH is only used to neutralize this carboxylic acid. That means the number of moles of NaOH is actually going to be equal to the number of moles of your carboxylic acid. So what you can say is that number of moles of NaOH is going to be equal to number of moles of carboxylic acid groups, and that's what you can say, that it is actually equal to number of moles of polymer. Okay, polymeric molecule. So you got the number of moles, right? That is actually equal to 2 into 10 to the power minus 4. Now the average molar mass, that is m naught bar, is going to be calculated by the weight which is given, how much gram of polymer you are taking. So you are taking 4.4 grams of your of the polymer, and divided by the number of moles, right? So that's how you'll get the average molar mass of it. So if you divide this, so it will be 2.2 into 10 to the power minus 4. Solve this up, and this is in grams, and this value you are getting in moles. So when you solve this, both the things, it will be how much? It will be 2. So you will get answer in 2 into 10 to the power 4 grams per mole. But the answer is asked in kg per mole. So how you will convert that? You will write down it as 20 kg per mole. So the answer is going to be option number 2. Okay, so it was pretty simple. You just need to know the basics, right? You just need to know the titration, how titration is being done, how you can convert number of moles from the given molarity, and just by putting all the things, you will get the solution easily. Alright, so I hope this is much clear to you guys. Alright guys, so that's all for this particular video. We have taken, I think, around 13 or 14 questions which were actually asked in your part B of your CSIR Net December 2019 exam, and I hope you guys understood it well. You guys liked the video, and whatever doubts you have, you can ask that in the comment sections below. And yeah, one more thing which I said in the starting itself, that If you have the question paper of the Assam and Meghalaya region, complete question paper, do send me. I will try to make the solution of that as soon as possible. So that's all from my side for this particular video, guys. If you are new to this channel, do subscribe to this channel. If you like the video, do give it a like. If you want to ask anything, you can ask in the comment section below. Thank you from my side, and that's all for this video. So thank you so much and have a great day.